Alrighty, let's go back to motion. Let's start with this thing called the position. Okay? In essence, where are you? Okay? I know where Tony is. I know where Joe is. I know where George is. I know where Megan is. Okay? I know where I am. But in one sense, where are we measuring from? You have to have a spot to measure from. And we have to have this stuff called units to go along with what that number is. And at this point, you may be looking at the screen and going, why does he have a picture of bacon on the screen? Well, for my physics students, one of the things I hammer home repeatedly is that if you pay attention to the units, it will save your bacon. Units are important. And I'll give you some examples here as we go along. So, how do we measure stuff? Well, we have these things called coordinate systems. And I've got several listed here, and I'm going to take you on a tour of them. So, as I said, I know where Tony is, and I know where George is, and I know where Joe is, and I know where Megan is. And I've got different ways that I could, make that known. I could use this thing called the geographic coordinate system with latitude, longitude, and elevation. It's just a way of identifying any point in three-dimensional space on this globe. And there's a latitude, a longitude, and an elevation above sea level that I could give for Tony, or for George, or for Joe, or for Megan, or for myself. That's one way of doing it. Now, if we look out into the night sky, we get to see stars and planets and galaxies and all kinds of cool stuff. Did you know there's a way to identify where everything is up in the night sky? There's an astronomical coordinate system. And it basically uses two numbers: right ascension and declination. Take a look at this picture I've got on the screen. That's a picture of the globe in the middle. Remember back we were talking about weather and going around the Earth traveling around the sun? We ran into that thing called the vernal equinox. Well, if we use that vernal equinox and then come around the globe as shown in the picture, and then go up from the equator, we can actually use that as a way to get a direction to a star or a galaxy or a planet or whatever. But it's just a way of saying the position of what we're looking at. Now, this is the one we're probably most familiar with. If we've ever, any of us, we've taken a math course, okay, we've run into this thing called the Cartesian coordinate system. Anybody know who came up with the Cartesian coordinate system?
Descartes.
Yep, good old René Descartes. I think, therefore I am, that guy. We've got our X, Y, and Z, three-dimensional space. We've got a sequence of three numbers. A lot of times we just work in X and Y, two dimensions, but if we get a third, we got a third number in there. It's a way to say where is something in three-dimensional space. There's another coordinate system called the cylindrical coordinate system, which uses two angles and a number. And then there's a simpler version called polar or path, where you use an angle and a distance to identify where something is. Okay. So most of the time we're going to use an XY axis system and just use that to give us a position.